Okay, last theorem of chapter 7. It's really easy, so we'll get right at it. It's called the side-splitter theorem. We start with a triangle, in this case triangle ACE, and I draw a parallel segment through that triangle. In this case it's labeled BD. BD can be anywhere from C down to AE. You've seen drawings like this before. You've solved them using similar triangles. So in other words, we realize that triangle BCD is similar to triangle ACE. Are you with me? So if we were doing this before today, we would say that BC is proportional to AC, triangle to triangle, and CD is proportional to CE, triangle to triangle. Side splitter says we don't need to do that. We can take a shortcut. This is all nice and peachy keen, but you probably don't get that. What you want to use is the following buzz phrase. Top over bottom equals top over bottom. Okay, look up here for a second. Stop writing. Top over bottom equals top over bottom. You don't have to compare triangle to triangle. For the two sides that are split, it's called side splitter because you're splitting the sides. Pretty clever, right? Yeah. So this proportion over here won't do you any good unless your triangle happens to be labeled the exact way that this triangle is labeled, which it's not going to be. Okay, we good? Can I move on or still writing?
Un momento.
Un momento. Bueno, gracias.
Sí.
Thank you. Yes.
You're welcome. No. I'm bilingual.
You are. Oh, congratulations. When did that happen?
Middle school.
See. Okay, now we good?
Wait a minute.
Sí, señor.
Wow.
Converse. Remember, converse go backwards. So in the previous slide, we started with parallel sides and said they're proportional. This is the converse, which means that if they're proportional, the sides are parallel. Right? No big deal. It's just a matter of what you start with. Did I start with parallel sides and get some proportionality? Did I start with some proportionality and get parallel sides? Let's get into some examples. Ready?
No.
No.
Sure.
Ready?
No.
Sí, señor. ¿Cómo estás?
Is there like a
¿Cómo estás?
So you can use that YouTube?
Muy bien, gracias.
Is
¿Dónde está el gato?
No, no tengo un gato.
¿No está aquí?
No.
Sí, ahí. Sí.
Sí.
Sí. ¿Muerto? No. Nicht sehr gut, meinen Schatzi. Was ist los?
What? That's Spanish.
No, sorry, that's German. I switched languages.
I was like, that doesn't sound.
Are we good? Did you have a question?
Yeah.
Oh, okay. Oh.
What else? Is there like a shorter way to, you know how you did like top to bottom equals top to bottom? Is there a shorter way to do like the converse? Is it like bottom?
Well, yeah, you could do the original theorem would then be if the segments are parallel, then top to bottom equals top to bottom. The converse would be if top to bottom equals top to bottom, then the lines are parallel.
Okay. Oh, I got you.
Okay, so we're gonna do this one together because it requires a little bit of explanation. Then once you get this one under control, life is good. First of all, what you can't see, because in my infinite wisdom I use bright yellow, is that there are little arrowheads there, so it does satisfy the side splitter theorem. Okay, that's number one. Number two, how long is this? Good. 37.5 minus x.
Wait, I thought. Never mind. No.
let's pretend you don't have the side-splitter theorem. Okay? We're going to do this problem the way we would have done it back in 7.1, 7.2, 7.3. Then I'll show you how the side-splitter works. Now, why am I doing this? Because if you forget the side-splitter, you can go back to congruency triangles. And we need congruent triangles to solve for y. Okay, so we're going to do a side note first. If we didn't know side-splitter, then I would say 9 over 22.5 equals 37.5 minus x over 37.5. Where'd the 22.5 come from? Yeah, this, 22.5. Okay, there's nothing new there. That's an old theorem comparing the top triangle to the big triangle. Solve this, please. I'll wait. All right, what do you got for me? Negative 22.5. How's that possible? You're crazy. Maybe. Anybody else?
I got a positive 22.
I'm still going.
I got x equals 22.5.
22.5.
That's what I got.
Yeah, that's the same.
All right, so of course the pen's not working anymore. There it is. As you can clearly see, 22.5. Okay, now let's do the same problem using side-splitter. So top over bottom equals top over bottom. Solve that for x. And if we have any idea what we're talking about, we should get 22.5, but I'll let you do the math. And trust that in fact we do get 22.5.
How is that easier?
Just different.
Okay.
It's the same, but different.
Ah, ja.
I think you get
Now we're laughing in Spanish too.
Laughing in Spanish.
How does one laugh in
Oh.
Spanish?
Ja, 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 ja.
Ja, ja, ja.
I don't get it, like, how do you sound? It's not, you spell differently. I'm like, ah.
Okay, we got 22.5.
Yeah.
Now to solve for y, side splitter doesn't apply because those sides aren't split. So therefore you can't use side splitter if the sides aren't split. Therefore, I have to do top triangle over, or small triangle over big triangle. Small triangle over big triangle is equal to small triangle over big triangle. Cross multiply, solve for y. Question?
Yes, so could you not do 9 over 13.5 is equal to 7.5 over y?
Nope. You will get an incorrect answer because those sides aren't split. Therefore, you can't use side splitter.
But isn't it, aren't they still?
But who knows? What we got?
18.42.
18.42?
Yeah.
No.
No.
96.75.
Yeah.
8.75.
18.
18.75.
Yeah.
That's what I tried to say. You 22.5 times 7.5?
Wait.
Oh, you did 22.1. You got all crazy. What is it, 18.5?
18.75.
7.5.
I blame Mr. Rudy.
I understand. I get blamed for a lot of stuff.
Yo comprendo.
Bueno.
See.
Nope. What are we doing? There we go. Boom. Good. All right. So, mid-segments. Remember we had a mid-segment in the trapezoid. We also have a mid-segment in a triangle. It's the same thing. It connects the midpoints. This is just like the side splitter, but it's a special case where R and I are midpoints. There are two things you need to remember about a triangular midsegment. Number one, they're going to be parallel. Has to be. And number two, it's half the length of the third side. So if we do this, and we do this, we have a midsegment. And it makes sense that it would be half, because if this is 4, this would be 4, which would make the whole thing 8, so we're in a ratio 1 to 2. So if this is 10, this would be 20. Not a big deal, just a variation of the side splitter theorem. Last little variation of the side splitter theorem is, what if we put more than one segment in there? What if I do this? All right. And then let's put another one down here.
Sound effects help.
I was hoping they would. Splits the sides into a whole bunch of different pieces. So let's lay, just to make things easier, we'll call that 1, 2, 3, 4, 5, 6, 7, and 8. The nice thing about adding multiple segments in there is that it's just the side splitter theorem over and over again. So you can match up any combination you want. If I look on the left side, I'm going to put 1 over 3. What would that be equal to? 5 over 7. Easy peasy? Good. I could do 2 over 4 plus 3. That would equal?
6 over 7 plus 8.
6 over 7 plus 8. Okay. Any problems? Beautiful. So take that and solve this problem. This problem. Right here. There you go. Solve for x, y, and z. Nope. Pretty. Anybody making progress?
No.
Yeah? No? No's across the board? Avery? Huh? It's a good start.
I don't know. I think I got Z.
Go. What proportion did you set up?
Z over 8 equals 1.5 over 6.
6. Where does 6 come from?
From the all the ones.
Beautiful. There's the key. You got to realize that that whole length is 6. Top If you look at it sideways, top over top equals whole over whole. It doesn't matter what combination you use. Top over middle equals top over middle. Top over bottom equals top over bottom. Whole over middle equals... as long as these two are the same thing. One variable, it's solvable. Avery, what'd you get for z? 2. 8.5 is 12. Good. Now, where do you go? Where do you go to from there? Anybody?
You do y over 2.
Can't,
I'm sorry, what?
You do
Y
y over 2 equals
over 2 equals
2 over 3.5.
2 over
3.5. 1.5.
1.5. Middle over middle equals top over top. That's 4 divided by 1.5. What is that?
Oh, 6. No.
What?
6?
No, that's 4 times 1.5.
2 and 2. 2.6 repeated.
2.6 repeated. That's sloppy, but I don't have any room to write it out. And then solve for x. And how you going to solve for x? You got a whole bunch of choices. X over 2.5 equals 8 over 6. Y over 2 equals x over 2.5. Y over x equals 2 over 2.5, etc., etc., etc. Question?
For y, could you done y over 2 equals 8 over 6?
Y over 2 equals, yep.
Oh, okay.
Yep. Okay, easy?
Easy.
Good. Last section of chapter 7. We should be done, and therefore I have a giant rabbit for you.